Okay, we're back. This is practice question number 3 from the CAEC practice test. I really like this one because it kind of makes you think on a couple of different levels. First of all, it's practical. We're looking at a table they give us in the question 2.25 meters squared. So it's a square table. Its area is 2.25 meters squared. Square table, area. That means the length and the width are the same. It's a square. They have the same sides. So if we want to find out what the length and the width are, we're going to have to take something called the square root of 2.25, and that is going to give us whatever this length is and this length. Now, it's a 3-dimensional drawing, so let's draw it in 1 dimension, or 2 dimensions rather. Like this, so that we know what we're working with. Now the question is saying, wait a minute, that's not it. We have a square table right now that's 2.25 meters squared. And it comes apart like most tables do, down the center, and then you can put leaves in it. So the leaf, it's saying, has a width of 40 centimeters. Well, right off the bat, everything we're dealing with is in meters. So why don't we convert 40 centimeters to 0.4 meters right now, and that'll save us a lot of trouble. If you're having trouble converting between centimeters and meters and millimeters and that sort of thing, that's just a quick review of the metric system. It's just a divisibility by and multiplication by 10. So we're just moving decimal points one way or the other. But if we're going from millimeters to meters, or meters to centimeters, centimeters to millimeters, we always have to be almost always in the same unit. So I'm just saving us a little trouble for right now. 40 centimeters is 0.4 of a meter. And if you think about a meter stick, and you want to know 40 centimeters, well, there's 100 centimeters in a meter stick, and 40 of them would bring you almost up halfway. Halfway would be 0.5, so 0.4 would be the 40 down here out of the whole 100, right? So anyway, 0.4 meters. Now the question's asking us though, we can put some leaves in here and they will be 0.4 meters wide. We're gonna have to know how long they are to fit the table. Well, that's easy because we know about square root and we know that the table is a square, 2.25 meters squared. And if you take the square root of it, put it in your calculator, 2.25, you will get 1.5. 1.5. 1.5 times 1.5 is 2.25 meters squared. So this is 1.5 meters, and this is 1.5 meters. So now what they're asking us to do though is we're going to split this table right down the center and have some of it over here and some of it over here. And we want to know how many different leaves we can put in, how many we need. 1, 2, 3. I don't know how many yet. That's the question. To increase the table so that it's now 4.05 meters squared instead of 2.25. So picture it in your head. We have a square table, we're going to pull it apart, and we're going to put in these leaves that are only 0.4 meters wide. And we want to put them in, and keep putting them in, 0.4 meters wide, times 1.5, because we know that now, it's a square root. So here's your table over here. We're going to take it and we're going to split it apart, split it apart, split it apart. These side lengths are always going to be 1.5 because we just figured it out. This one here, we're starting to put in pieces that are 0.4, 0.4, 0.4. How many do we need? Well, that means we have to figure out how much area we're putting in here every time. And how much do we want to increase the table to? Wow, there's a couple of different things going on. Well, we already know what we started with and we know where we're going. So if we want that table size to be 4.505 meters squared, how much more area is that? Well, that's just a subtraction. 4.05 minus 2.25 is how much? 5 minus 5 is 0. 4, 1 from here. 8, 1, Well, that's 1.8 meters squared more. We need 1.8 meters squared more to get 4.05 meters squared in our new table size. But these little sections only come in 1.5 times 0.4. Well, how many of these will we need to get 1.8 meters squared? Well, why don't we find out what the area of one of those sections is? What's one of the sections here? What's the area? This is going to be 1.5 times 0.4. 1.5 times point. Well, that's an easy one. 1.5 times 0.4. 5 times 4 is 20. 2. 4 times 1 is 4 plus 2 is 6. 2 decimals, 0.6. So every one of these inserts is 0.6 meters squared. And we need enough of these to make up 1.8 meters squared, because we need more. We need 1.8 meters squared more to get to a table that's 4.05. A lot of decimals in this one, but the numbers are easy to work out. If you're quick and you know your times table, 6 times 3 is 18. 3 times 0.6 is going to give us 1.8. So if we really wanted to figure it out and see how many of these fit into the how many we need, you would take this number and divide it by this number. So let's do it. 0.6 into 1.8. Now, good way to do this one, the nice test, I was taught a long time ago, is we get rid of this decimal here and bring it over, which means we get to bring this one over 1 as well. So now we have 6 divided into 18. Does 6 go into 1? No. Does 6 go into 18? Yes. 3 times 18, 0. That means, putting it all together, we have a table that's 2.25 meters squared. We want to split it apart and add sections to it so that we increase this 2.25 to 4.05. Okay. We're going to need to know some numbers. They're telling us it's square for a reason, so we can figure out what this length is. We figured out that length because we took the square root of that number. This times this will give you this. These numbers are the same. You put this number in your calculator, you hit the square root button. Sometimes there's a little 2 here, and you get 1.5. That means that this length is 1.5 and this length. That's a square table, 1.5 times 1.5, 2.25 meters squared. Now, to the question. You got these leaves, 40 centimeters. Wow, let's deal with meters. 0.4 meters. Well, we know the length of it has to be 1.5 because it has to match the table side. And then we want to know how many of these we need to insert so that we bring that whole table up to 4.05 meters. So we should figure out how much bigger the table is. 4.05 minus 2.25 is 1.8. That's how much bigger the table has to be. 1.8 square meters. Well, we're already defined by these, how our bigger our inserts are. How many of these do we need to make 1.8 meters squared? Well, if this is 1.5 times 0.4, that means this is 0.6 meters squared. So we're going to need 3 of them, because we divided 0.6 into 1.8, 3 of them to make up that difference. So over here, instead of 4 of them, what we thought, we're going to need 3 of them. This will be 1.5, these will be 0.4, and in between here will be 0.6, 0.6, 0.6, and on the end 2.5, 2.2, 2.2, well, divided by 2. These together here will be 2.25 plus the 1.8 in the middle. If you wanted both sides and it was split evenly, you just divide this. Well, you know what? Let's do it. 2 into 2.25. Is 2 going to 2? Yes. Bring down the other 2. Is 2 going to 2? Absolutely, yes, once. Is 2 going to 5? Yes, twice. 4 4, there's 1 left over, this 2, yes, 10. Bring down 0, 0, 0, 2 is 10, 5 times, 1.125. So this would be 1.125 meters squared, and this would be 1.125 meters squared. All of them added up together was going to give you the 4.05. The answer is how many of those leaves that you needed, and we figured out a little while ago that it was 3. That's all there is to this one. We'll see you next time.